this video, we'll be looking into the given problem statement that says let S be the set of all non-zero integers and set A is equal to S cross S. On the set A, the relation R is defined by A comma B related to R, A comma B belongs to R and C comma B belongs to relation R if and only if AD is equal to BC. So here we have to prove that R relation R is equivalent. So firstly, we know that for a relation to be equivalence, it has to satisfy the symmetric condition, transitive condition and reflexive condition. So only if it satisfies all the three conditions, then it is said to be equivalence. So now let's solve one by one. Let's look into one by one these relations. So first let's take reflexive. A relation is said to be reflective when all the elements of one set are related to each other. So here you can write. So here the set belongs A's. The set contains A's and B's, C's and D's, right? So we can say that A comma A belongs to R. So A comma A is equal to A comma A. Thus it is reflexive. Then we have reflexivity, yes. Then you have symmetricity. So for symmetric, we know the condition A comma B belongs to R. Then B comma A should also belong to R. So looking at the example here, we have A comma B and C comma D belong to A. Then we can write A comma B related to C comma D is equivalent to A comma D related to C comma B. We have to understand this because in the given condition they have said AD is equal to BC. So similarly, we can write C comma D related to A comma B. CB is equal to DA. As we know that C comma B can also be written as B comma C and B comma D can also be written as D comma B. So this condition is being derived from the given problem statement. Thus we can say that A comma B related to C comma D is equivalent to C comma D related to A comma B. Thus we can say that the relation is symmetric. And third, we have transitive condition. We know the condition, that is A comma B. If A comma B is related to R, then C comma D should be related to R. And followed by that, let's take E comma F also related to R. So let's prove this. Let's take AD is equal to BC and CF is equal to DE. So from this we can derive C is equal to DE by F. This C value, let's place it here. So it will be AD is equal to B into DE by F. Here DD gets cancelled. This F, send it on the left hand side. So it will become AF is equal to BE. So here we can say that A comma B is related to E comma F. So that is what the condition is, right? So A comma B should be related to B comma C. A comma B should be related to C comma D. This should be further related to E comma F. That is, we can make out a statement that A comma B should be related to E comma F. So this condition is being satisfied here. Thus, it is transitive also. So When a relation satisfies the reflexivity, symmetry, and transitivity conditions, it is said to be equivalent. So here we have proved that R is equivalent. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.